If you've reached this point in the class, doing the readings and successfully doing the exercises, congratulations. You may now call yourself a computer programmer. Welcome to a very elite club. Up to this point, we've worked on relatively small programs. We usually measure the length of programs by the number of lines of code they contain. Lines with only comments and blank lines don't usually count. Some people count lines with single curly braces and others don't. Lines of codes is one of the ways that employers keep track of how much work a programmer has done. The biggest program that you've probably written as a part of this class was around 200 to 300 lines long. That's a substantial intellectual achievement. The programs that commercial software engineers write can have millions or even billions of lines of code. The next big challenge that you'll encounter in programming is learning how to organize programs to better be able to manage the complexity of larger programs. To do this effectively, you need to be able to control more complicated relationships between classes. So far, we've seen two relationships between classes. One class can use another class. For example, most of our classes use the string class because their toString method returns a string. Another relationship between classes is called aggregation. This happens when one class has instance data from another class. For example, a class that stores addresses will aggregate string objects. If you look back at your code, you'll see that these are the only relationships between classes that we've used so far. An example of a more complicated relationship is inheritance. Inheritance is used when you need to create a class that's similar to an existing class, but has some special properties or actions. For example, when we program graphical user interfaces, there's a class called AbstractButton that has all the functions you'd expect. When it's pressed or released, some action happens. There are lots of Java classes that inherit from AbstractButton, like JButton, JMenuItem, and JToggleButton. JButton is a plain regular button like the buttons that let you debug or run programs in Eclipse. A JMenuItem is also an abstract button. That one may not be as obvious, but if you think about it, you select a menu item and some action happens. And that's button-like. JToggleButton is used to allow users to select a button that works like a light switch. An example of a JToggleButton is the P button in Eclipse that either shows or conceals the white space characters. The action that happens with JToggleButton includes keeping the button down or up until it's hit again. So each of these buttons has some special action that's related to the general idea of being button-like, but they do something special. Inheritance plays a very important part in object-oriented programming and is one of the relationships between classes that you need to master if you're going to continue programming in Java. One of the sad facts of programming is that commercial software engineers produce only about 6 lines of code per day of programming that's actually delivered to customers in the product. That probably sounds impossible to believe, but it is true. Of course, software engineers write many, many more lines of code than this, but those lines don't make it into the final product. We know that the difference in productivity between the most productive and the least productive software engineers is more than a factor of 10. Some people think it may even be a factor of 50. That's a huge difference. If you want to be one of the more productive programmers, you'll need to continue to learn more about Java or some other programming language and continue to practice programming. There are lots of ways to do this. Of course, you can take more classes, like CS 2334, Programming Structures and Abstractions at the University of Oklahoma. This is a second semester Java class that covers more complicated relationships between classes like inheritance, shows how to manage user and program errors better using exception handling, and helps you use the Java API more effectively, amongst other things. You can also read books about Java. The challenge you'll run into right now is that you're probably somewhere between a beginner and an expert. There are lots of books for beginners, and there are lots of books for experts, but there's less in the middle. Many of the books for beginners are so big, sometimes 8 or 9 pounds, because they try to give beginners enough information to bridge that gap. And those books can be a good place to start. As you move towards being a more advanced programmer, a book you might enjoy is Java Puzzlers by Block and Gafter. Joshua Block has also written several books on how to program well in Java and some of the pitfalls that Java programmers encounter. One of my favorites is called Effective Java. It's considered required reading by anyone who programs professionally in Java. O'Reilly is a publisher with some outstanding books on many computational topics, including Java. I like their Nutshell series of books, particularly Java in a Nutshell. I have more than a dozen O'Reilly books within arm's reach right now. Another way to learn about programming is by visiting programming websites. Be careful which ones you choose because there's a lot of really bad code and even worse advice out there. One of the better websites is the Oracle website on Java. They have lots of great learning materials, although they're usually pretty advanced for beginning programmers. Although it can be frustrating to read materials for more advanced programmers at first, it does get easier with practice. Another way to grow as a programmer is to pick a pet project. This is one of my favorite ways to learn to program in a new language. As you encounter new challenges, you use books and websites as resources to learn the parts of language that you need at that moment. Many of the big international companies that employ our graduates have told me they won't consider hiring anyone who hasn't done some programming project just for the love of programming. Choosing a personal project can be tough. Many students want to program games, but unless the game is modest, it can be so overwhelming that it never gets started, let alone finished. It's probably better to write a program to play tic-tac-toe or Tetris rather than to try to program your own personal World of Warcraft. You'll have more fun if you find some friends to program your project with you. You'll also be more likely to stay committed to the project and get it finished. A finished personal project, even if it's small in scope, will make a much bigger impression on a future employer than an unfinished mass of code that doesn't run. And just because you're programming for yourself doesn't mean that design and documentation aren't important. No future employer ever wants to see undocumented code. So we will part company, at least for now. I hope that you've discovered the love of programming in this class and that you have as much joy building amazing software as I've had. Good luck and happy programming.